Welcome to this explainer. Today, we are diving into the rigorous, completely data-driven world of process improvement. We're going to uncover exactly how top companies literally fireproof their operations. I mean, if you've ever wondered how the most successful organizations out there avoid catastrophic failures and just consistently deliver flawless products, well, you're in the exact right place. We're unpacking the mechanics of a methodology that has literally saved companies billions of dollars.
So, 3.4. That number represents the Six Sigma standard. It's a target of no more than 3.4 defects per million opportunities. Just think about that scale for a second. Whether you're manufacturing a complex jet engine or processing a massive stack of financial transactions, this methodology demands a level of precision where an error is an absolute staggering rarity. It is a relentless pursuit of near-perfect performance. But this really begs the question, right? How do businesses actually reach this level of breakthrough performance without relying on sheer luck or guesswork? How do you take a chaotic, error-prone process and systematically re-engineer it to hit that strict 3.4 threshold? Because it doesn't happen by accident. And it certainly doesn't happen just by telling your employees to quote-unquote work harder. So, to break this all down, here is our roadmap for this explainer. 1. The quest for perfection. 2. Old ways versus Six Sigma. 3. Decoding the DMAIC framework. 4. DMAIC in action with Wipro. And finally, 5. Sustaining flawless performance. Let's kick things off with Section 2, Old Ways versus Six Sigma, from reactive to proactive. For decades, companies relied on what we call inspection and rejection. They build a product, test it at the very end of the line, and literally just throw away the defective ones. It was a completely reactive, incredibly expensive way to do business, and it often relied heavily on management's gut feelings. Well, Six Sigma flips this entire concept on its head. It is entirely proactive and completely data-driven. It demands that decisions are made exclusively on verifiable statistics, all to prevent the fire from starting in the first place. And it goes further than that. Six Sigma elevates quality from being just a simple factory floor expense to a major strategic imperative. This is led by highly trained change agents, you might have heard of black belts and green belts, who drive genuinely quantifiable financial returns. In the old days, the quality department was this isolated group viewed purely as a cost center. But Six Sigma transforms quality into a massive profit growth engine. It creates this pervasive cross-functional infrastructure that aggressively attacks the cost of poor quality. We're talking about all those hidden wastes, scrapped materials, warranty payouts, lost customer trust. Eliminating those drastically boosts the bottom line. Moving on to Section 3, Decoding the DMAIC framework, structured problem solving. Okay, so DMAIC. This is the fundamental data-driven framework that organizations deploy when an existing process is underperforming or producing defects due to totally unknown root causes. And it's really important to highlight the word existing here. DMAIC isn't for inventing something completely from scratch, no. It's the ultimate tool for taking a process you already have, one that's bogged down with rework, delays, or customer complaints, and methodically optimizing it until it runs flawlessly. Inspired by Dr. W. Edwards Deming's scientific methods, DMAIC actually chunks process improvement into 5 distinct, rigorous phases that teams systematically work through. It's an acronym standing for Define, Measure, Analyze, Improve, and Control. By following these exact steps in strict order, teams are able to cut through the noise, completely bypass the guesswork, and actually implement solutions that stick. Let's start with the D. The define phase is absolutely foundational. It requires teams to narrowly describe the exact problem and clearly map it to what the end user actually values. I mean, you can't fix a problem you haven't clearly identified, right? In this phase, the team sets incredibly strict project boundaries, so the scope doesn't just creep out of control. Most importantly, they listen to the voice of the customer to establish exactly what is critical to quality, or CTQ. Think of it like this. If you're making a pizza, a perfectly crispy crust is a CTQ metric. The exact color of the cardboard pizza box? Probably not. All right, once defined, we hit the measure phase. This quantifies the extent of the problem by gathering original, reliable data to establish a rock-solid baseline. You have to know exactly how badly the process is performing today, otherwise, how can you prove you actually fixed it later? Teams develop highly specific data collection plans here, and this is also where powerful tools like failure mode effects analysis, or FME, come into play. You can think of FME as a sort of statistical crystal ball. It lets teams systematically look at a process, anticipate exactly what might go wrong, and predict both the probability and the impact of those potential failures way before they ever happen. Next up is the analyze phase. Here, the goal is to separate the vital few causes from the trivial many. This is absolutely not about a bunch of managers guessing what's broken in a conference room. This is about letting the data speak for itself. Using visual tools like Pareto charts or cause and effect fishbone diagrams, teams investigate the precise when, where, and why of every single defect. They deploy sophisticated statistical tools to pinpoint and rigorously prove the absolute root cause of the variation until there's literally no ambiguity left.
So with the true root causes proven, we enter the improve phase. This is where teams get to creatively brainstorm and pilot solutions. Once you know exactly what is causing the error, you can design a highly targeted fix using techniques like the design of experiments to systematically test different process adjustments. They also implement mistake proofing, which is known as poka-yoke, to make it physically impossible for that error to ever happen again. Think about how a SIM card has that one clipped corner, so it can literally only fit into your phone one way. That's poka-yoke in action. And of course, everything is carefully pilot tested to verify it actually works in the real world before a full deployment.
Finally, the control phase acts as the anchor. It implements continuous monitoring systems to ensure the process never reverts back to its old, defect-producing behaviors. Because let's face it, human nature often dictates that people will just slide right back into their old habits. The control phase locks the new standard in place for good. Teams finalize the documentation, they train the staff, and they set up statistical process control charts to continuously monitor key variables. They even write up formal response plans. So if the process ever starts to drift out of alignment, frontline operators know exactly what corrective actions to take instantly. Let's look at Section 4, DMAIC in action. Wipro, from theory to practice. It's time to shift our focus from the physical factory floor over to the server rack. Wipro Technologies actually became the very first Indian company to adopt Six Sigma, and they proved that this wasn't just for physical assembly lines when they applied the DMAIC methodology directly to their non-transactional software development processes. People often mistakenly assume that Six Sigma is exclusively for manufacturing physical widgets, but Wipro demonstrated perfectly that the exact same principles of reducing variation and eliminating defects apply beautifully to writing code and managing IT systems.
To give you an idea of the scope here, Wipro was tasked with overhauling a major application for a leading U.S. telecom provider. And the goals were absolutely critical. They needed to shorten data transfer times and avoid any unacceptable LAN and WAN downtime interruptions. This wasn't just some minor glitch. It was a severe business risk that required a heavily disciplined intervention to stabilize the telecom product's performance and significantly reduce risk.
By rigorously applying those 5 DMAIC steps, Wipro achieved incredible results. They successfully transitioned from merely identifying critical defects to delivering massive cost savings and incredibly robust product performance. They used the define and measure phases to truly gain a quantitative understanding of the upstream software processes that were actually causing the lag. They analyzed the bottlenecks, improved the code and deployment protocols, and drove continuous performance improvement toward flawless quality. The result wasn't just slightly better software, it was a completely transformed process.
And that brings us to our final section, sustaining flawless performance, the future of quality.
While DMAIC is undeniably your go-to for fixing existing processes, it is really important to note its counterpart, DMADV. DMADV is utilized proactively when a process is just so fundamentally flawed that it needs to be built entirely from scratch. It stands for Define, Measure, Analyze, Design, and Verify. Think of it this way. If your car engine is sputtering, you use DMAIC to tune it up and fix the broken parts. But if you suddenly need a vehicle that can fly, well, you can't just tune up a car engine. You need to build an airplane. That is exactly when you use DMADV, which is also known as Design for Six Sigma, to build flawless performance right into the blueprint from day one.
The legendary quality pioneer Joseph J. M. Jurin famously warned us against the dangers of reactive management. He said that the traditional approach depends on an inspection and rejection process to find and correct quality problems in individual products, without ever redesigning the planning process itself. And that right there perfectly highlights why the proactive redesign inherent in Six Sigma is so revolutionary. Jurin understood that simply catching errors at the very end of the line was a completely failing strategy. By using DMAIC, organizations stop treating the symptoms and finally cure the underlying disease. They redesign the process to ensure that quality is a guaranteed output, not just some lucky coincidence. Ultimately, the methodology is crystal clear. So I want you to take a hard look at your own organization.
What is that one notoriously broken process? You know the one that always runs late, constantly bleeds budget, or just endlessly frustrates your customers. The data to fix it is probably hiding in plain sight. So the question is, are you going to keep putting out fires, or are you ready to define the problem and engineer perfection?